should be recording. So what I'm going to start off with is I'm going to just do a quick recap of what we've already done in term 1 and the first chapter of the textbook. Now you've got to remember that we only have 3 terms to cover this textbook, so we do have to track it a little bit faster than 1 chapter per term. So in this first chapter, I won't go through the syllabus outcomes. You guys can read those at some we actually went through them in class, but I won't go through them again now. Now, this area of engineering practice and historical and social influences, they're pretty similar usually every chapter, especially in the HSC year. They become very similar year on year. So in the first chapter, we talked about the nature and range of work of engineers. So we looked at that using a file, a PowerPoint file that should be on Facebook. And I have an audio recording where I went through that at the same time. And that's on the engineering colleges as per the Engineers Australia, the accrediting body in Australia. Okay, so historical developments in people's lives. We went through the timeline wall. We spent 2 lessons talking about that. And the effect of engineering innovation on people's lives. We used bridges as our example, where we looked at bridges and talked about the benefit of bridges, things like level crossings. Okay, so for mass, force, scalars, and vectors, simple machines, we mainly watched the Eureka videos and we added some stuff on there. So, okay, in terms of going on this side, this is what you're supposed to learn about and what you'll learn to do. So you have to learn to identify different types of engineering. You have to be able to outline historical uses and applications of materials in the design and project of engineering products. So this is where we talk about things like the use of steel or stone and that sort of stuff. Okay, I'm just checking that I don't have video recording at the moment for people on. We want to record that. Thank you, that was an excellent comment. Go live. Okay, so we're back to the screen and okay, so use of mathematical and graphical methods. Now we've done a little bit of this, but not very much. So learning about vectors and addition of vectors, that's something we're going to focus more in this next chapter that's upcoming. So we've talked about the concept of vectors, but some of you guys may have done this in physics already. We're going to learn about the addition of vectors. And that's pretty important. This is one of the fundamental things that we have to do in this course. So I would say the cornerstone or the touchstone, the thing that is the central focus of this subject is being able to find reactions of beams. That's actually the thing that is most likely. It's been in every single exam. I used to say trusses, but trusses build upon that initial focus. And there was one year that there was no truss. I lost a lot of face on that year. That was actually Alexei's brother's year. And they joked about me having to give them a house, and that they were all happy to share, that they could share the house. They'd divide up the rooms themselves. But anyway, okay, G'day. Examine the function of simple machines. So we've talked about simple machines a little bit, but we haven't gone to that with the depth and detail that I'd like, because we're sort of really preparing for an exam. But we've watched videos and we've talked about those things. So we'll come back and talk about that a little bit more in a second. Okay, so for engineering materials, we've learned about the classification of materials, and students should learn to classify materials. That means there's 4 different categories. You should be familiar with those. If you're not sure what those 4 are, you need to send me a text and say, puns, I don't understand what the 4 classifications are. Okay, we did properties of materials. Now, there were physical, like things like thermal, electromagnetic. Physical is things like density. There was things like chemical properties, which is your corrosion. But generally in engineering, the thing that we really do that stands out is we're interested in mechanical properties. Things like toughness, hardness, strength, elasticity, plasticity. That is the key that we're really talking about. So if you don't know what those things are, you need to look those up. Or send me a text saying, puns, I don't know where they are, and I'll show you the page where they come from. Okay, so that's that. Structure of materials. Okay, so we've learned about the atomic structure. So you should know that there's 3 subatomic particles. If you don't know what they are, you need to let me know. There's also 3 kinds of bonding. If you don't know what they are, you need to let me know. There are, in terms of crystalline, most solids are crystalline. So things that aren't crystalline, there's a special word for that. That's if you don't know what that word is, you need to let me know. Some things can be in 2 forms of crystals. If you don't know what the word is for that, you need to let me know. But for the main crystal structures, we have face-centered cubic, body-centered cubic. There's other ones that are also interesting, but not focused on as much, which is hexagonal close-packed and things like BCT, body-centered tetragonal. So we're going to talk about those later, but really for the moment, you probably would only need to know FCC and BCC. We'll talk more about that in this topic. Okay, so in terms of metals, there's the big three of metals is iron, the ferrous metals, aluminium, and copper metals, FAC, FAC. So you should be familiar with the breakdown of ferrous metals, so things like wrought iron, cast iron, steels. You should know which one is the most commonly used. They're probably the main things to think about there. For aluminium, you don't really need to know too much about that, except to maybe discuss what are the good properties of aluminium, things like its weight properties, its corrosion properties. That's probably its main things. In terms of copper, you need to know bronze and brass. That's it for the moment. You'll eventually need to know things like copper cadmium and copper beryllium, but they're actually right in a year's time. They're right before you do the HSC that we learn about that. My year 12s haven't done that yet. So you need to know about where the appropriate use of bronze and brass is and stuff like that. And you need to know what the alloying materials are for that. Okay, for basic forming, so I have discussed and provided examples of casting and videos of casting, rolling, extruding. Now, not so much cutting. Joining, we talk about welding. I'll talk about that in a second, and fabricating generally. Okay, so really what we're interested in is these first three, and there's one more that is forging that doesn't seem to be on that list. Okay, so casting is its own thing. I don't think I can flick between windows very easily, but if I went to the Facebook post, we could see that, let's see how hard that is to do. So I want to go to Safari, and then go to Scantium, and you guys probably can't see anything yet. Close that chat. Okay, switch the Discord window. Change screen to Scantium. You guys, could you send me a text just to say that you've seen that the change in screens? So, if you look at this window, at this page, okay. Okay. It's a shame because I'm going to have to close that window again in a second. So this is where just doing whole screen share could be better in the long run, but for the moment we'll see how we go. So these are fabrication methods. Now there's fabrication methods is the whole family, and then you've got three uncles: forming, casting, and joining. And forming has four kids: forging, rolling, drawing, and extrusion. I do tend to forget drawing. It's not specifically called out in the syllabus, but in drawing, it's for wires and tubes and rods. But you should be familiar with an example of each of these, and there's videos that you can watch if you're not entirely comfortable with those things. So things like investment casting is worth pointing out. And that aluminium can is just an interesting video, but it's not something we're really going to focus on until year 12. But often I like to have things ready for later. Okay, I'm going to try changing my screen back to the syllabus. If I had the syllabus open here, open a new tab. Let's see if that will work. And then that way, yeah, boom. That way I won't have to change screens. Just forgive me while I do the motion sickness stuff for a second. Okay, that's pretty close. Okay, polymers. Well, polymers are long chains of carbon compounds. Okay, so we have two groups, two families: thermosoftening and thermosetting. There's about 11 thermosoftening polymers we need to know. So, funnily enough, I was talking to my wife about this yesterday. I think she's in earshot. So number 1 is PET. Number 2, the plastic's so nice they named it twice, is HDPE. Number 3 is PVC. Number 4 is low density polyethylene, so the shrink wrap. Number 5, the challenger like Rocky, is polypropylene. Number 6, polystyrene. Polystyrene's probably the one that's on a bit of the way out. Okay, so the extra 5 or so that we need to know. Excuse me. We have headlights and taillights. Headlights is polycarbonate. It's very hard, very clear, but not and good impact resistance, but it's not as easy to work. Whereas we have, on the other hand, acrylic, which it has a lot of those properties, but not quite as good. PMMA is the letters for acrylic. We have the two 3D printing polymers. We have PLA, which is the biodegradable one, and ABS. ABS is a copolymer, which means that it's made up of multiple polymers. The last one is Kevlar, or nylon, which is polyamides. They're the thermosofting polymers. For thermosetting polymers, look, if I'm writing a test, if you see the word epoxy, the word resin, it's a thermopolymer, thermosetting polymer, sorry, that's a big difference, a thermosetting polymer. Silicone with an E, silicon, but spelt with an E, silicone, is a thermosetting polymer. And I'm just trying to see if there's any other before I get to the big two. The big two are phenyl formaldehyde, which is a condensation polymer, which means that when it's a copolymer and a condensation polymer. So it's made of two groups of phenyl and one group of formaldehyde, and when they join together, they make the polymer. The polymer phenyl formaldehyde and water, H2O. So because of that byproduct, they call that a condensation polymer. The other one is polyurethane. Polyurethane is used in things like fake leather and foam. Okay, so that's a comprehensive list of polymers. I will post some more stuff up about that, but for the moment that will get us out of trouble. Okay, ceramics. In the next week, we're going to go back over polymers. Ceramics. We've talked about ceramics. So if I go back to Scantium, this is my picture of ceramics. So I've got glass, brick, concrete, or cement products rather, which includes concrete. We've got diamond, that's a diamond blade, and ceramic insulators, so it's a spark plug with ceramic on it. And when I go back to the syllabus here, okay, so we've also talked about timber. We haven't gone into too much detail for timber. We've just outlined the properties and uses of composites in engineering. Okay, so we've just talked about, we've outlined the use of timber and concrete. So in the case of timber, I don't know if I have a picture yet of timber. If I haven't, we should do that. In composites, here we go. Okay, so this is sufficient for composites. So timber, but furthermore we have examples of LVL, which is this one here, laminated veneer lumber, and glue lamp, which is this one here. Okay, so as we go back to the syllabus, let's see what else we have here. Okay, so we have communication. So we haven't done research methods. A lot of this stuff when I have to write in my register, so for my legal, insurity that I've done these things, I just say this will be taught next term, which is the case here. So freehand sketching, we've done a tiny bit of, and that's what we're going to start focusing on for the next term. Research methods we'll do this term, collaborative work we'll do this term, and the engineering report we will do next term. So we'll do that as part of chapter 2. Okay, so at this point we're just doing the quick look ahead. We're going to see what do we have to learn in the next chapter, which we should be finishing sort of in 8 weeks or so. Okay, so we have skills of the professional engineers, so the problem solvers, designers, communicators, project managers. Now, for those of you who were on the chat before I started this recording, that will look familiar because that is literally what the first few pages of the textbook says. Okay, if we then go to historical and social influences, we're looking at various engineering products. The two various engineering products we're interested in are bikes and lawnmowers. The effect of engineering products on people's lives, the same thing we talked about earlier, and the implication of engineering products, where we're talking about things like social and environmental implications. That usually, it's always worth talking about things like greenhouse gas emissions contributing to climate change, which contributes to drought and increased natural disasters. Social impacts are things like increases in productivity, economic benefit, but also things potentially like social isolation and anxiety. So there's a very, very complicated things when we're talking about social, but they're both positives and negatives there. Okay, so moving on to engineering forces. So forces, we have already done some of this, So we've talked about the nature and type of forces. Let me find you that page. I think it's the Star Wars picture. I used to have a different picture. It used to be my forces picture. Waiting for this to load. Used to be what this picture is here. The four or five different types of engineering forces. Oof. There we go. Okay, so this is my force picture. So there's different types of forces that we're going to worry about in this subject. We don't really worry too much about torsion, but we'll get to that in due time. But stuff like this map of physics and what is something where they talk about forces being the rules of the game of life are quite interesting, but it's also, I don't want to get too bogged down on that. So that's where I leave it as sort of extension, and then I leave it for you guys. When we start talking about things like space body diagrams, resultants, and equilibriums, that's all stuff that we can look at later. I did see that message. Yeah, look, I am hopefully recording this, so I should be able to put this up for people who see it later. Moments of a force and the couple systems, that's all this is like the bread and butter of this course. So if you felt as though there hadn't been enough maths yet, this is where the maths comes in. Okay, so for materials, we're going to learn about, and this is something I really actually enjoy talking about, so the modification of materials, heat treatment. So I enjoy talking about heat treatment. So if I go to calcium, and I can show you the calcium notes, because they're a year ahead of you and they have better notes. I also have a song about Brosse les Dents. Okay, so this is their heat treatment notes. So I'll quickly go through just a very quick brief summary. So this chart shows the different versions of steel depending on, when we talk about heat treatment, we're initially only going to talk about heat treatment of steel, which makes a lot of sense because it's the most important and most commonly used. We will eventually talk a little bit about heat treatment of stainless steel and aluminium, mostly a form called precipitation hardening, and a little bit about cast iron, but that's further down the line. So if we look at steel, we have different forms of steel. We have austenite, ferrite, and pearlite. There's another one called cementite. I don't know if I have a picture. There we go, cementite. That's my picture for cementite. There's semen, right? Because semen, other teachers, they pronounce cementite as cementite, which I suppose is probably just a different stress on the vowel. But anyway, so there's different semen there. But so this here is a zoom in on that section of a bigger chart. So let me have a look at the bigger chart. Where is that? Oh, here. Okay, so this is the zoom in of that bigger chart. You can see those colors are there. This is the zoom in of that bigger chart, but what we're interested in is these four forms of steel: austenite, ferrite, pearlite, and cementite or cementite. I always say cementite because that's what I heard when I was a kid. Okay, so, and I think that's what I heard at uni. Anyway, okay, so ferrite, that's a ferret, right? And the ferrite is body-centered cubic. Down the line, or maybe you guys can look up, I for some reason use Alison Brie, who is an actress in Community in BoJack Horseman, and I use that to help me remember body-centered cubic, but I maybe we'll talk more about that later. Face-centered cubic, I talk about this, it's a form of steel called austenite, which is face-centered cubic, because look at his face, you know, like he's got his teeth, they're not so great, so he's got a messed up face. Pearlite, we're going to remember as punset, right? And it looks a bit like a zebra, so that's a picture of me with a zebra on my head. So that's how we're going to remember pearlite, as pearlite is a mixture which it's in layers. So you'll see more about that later. I do have a audio recording where I go through a fair bit of detail on that as well. But anyway, so plenty to go through there. When we talk about the heat treatments, this is the wrong way. We're going to learn about three main heat treatments of steel: annealing, normalizing, and tempering. And I use the three avatars as my way of remembering that. If you haven't seen the TV show Avatar, good thing to do to watch over this extended break. So that's something for you to look at. I do maybe have some more on heat treatment. Okay, so I used to use reiterations of Bond, like, you know, because there's been multiple James Bonds, and I thought that made a lot of sense, and then I realized that a lot of kids hadn't seen James Bond, or they didn't know really more than one James Bond, so a lot of this nuance was lost. And I thought, well, the Avatar series, they're reborn, and I thought that was a good way of remembering that concept. Okay, so we'll talk more about that when we get into it. Okay, so the next thing we're going to do after we talk about engineering materials, we've got these work hardening, right? Heat treatment, alloys, applications. So we're going to talk about where we use these different materials. We're going to talk a little bit about recyclability of materials and the cost and benefits of recycling. So we'll talk about that before the end of the chapter. Okay, engineering electronics. So we're going to learn about the basics. So for that, I have, and it should be in our files. If I go to files, there should be open the Manga Guide to Electricity, Chapter 2, where I just talk about the very basics of electronics, stuff that you should have done in science already. But we're going to see how that's applied. So if we go to calcium pictures, we can see, so all of my stuff in electricity, I will put in one big post. And the post for that is this post here from The Office. I don't know if you guys have seen The Office, but it's a good show. Definitely worth watching again. Would I watch The Office or Avatar over, which one would I watch first? Oh, look, they're both pretty good. I do say that, often say that Avatar is my favorite TV show. The Wire is probably my favorite TV show, but Office is pretty good. It's good. It's just it's longer, so there's more of it. I don't know if you can hear this. You maybe can't hear that.
They call it Scranton. What? The Electric City. Scranton. What? The Electric City. Lazy Scranton, the Electric City. They call it that because of the electricity. The city.
And there we go. Hopefully you were able to hear that a little bit. Anyway, I'll post that when for you guys, but that's just so that when you know where to look for. I did have the alternative version, which again, I'll go into more detail, is so I had a poll, and my year 12s, they decided that they wanted Scranton, what, the Electric City, over Electric Dreams, which was a movie that I saw when I was a kid, like 6 or 7 sort of thing. And I thought it was left a fairly big impression on me, this movie. Oh god, it's an ad. And skipping ad. It's a movie from the 80s about a guy who pours champagne on his computer, and the computer becomes alive and then falls in love with his girlfriend and then tries to ruin his life. Anyway, so I'll show you that one later. I just want to see the smiley face. Oh, well, we'll get to it in due time. Okay, so you can decide if maybe you don't want the Scranton Watt picture, but I think they're probably right by going with the Scranton Watt picture. Okay, so we're going to talk about magnetic induction. So that's all within these notes. If we go back to... So if we have a look here, we learn about things like... Oh god, there's a lot of posts, because I just put so much here. So first, when we talk about induced current, the main value we have for that is creating motors. So you may have, in physics, you may have made your own coil motor. But then we're going to learn about different motors, so DC motors, AC motors, brushless AC. We're going to learn about things like back EMF. I talk a fair bit about nuclear power and wind power, how Joe Hockey and Trump don't like it. So we're going to look about how electricity is generated. This guy is pretty good. He talks about AC versus DC. A lot of so I'm on like Reddit on engineers, subscribe to Ask Engineers and things, and they always talk about how this guy just is such a great way, such a great resource for electrical engineers. The other side of the renewable data, this guy gives quite a sobering look on how much can we actually achieve with renewables. So that's worth looking at, and maybe I'll make that for homework. Okay, so some more stuff on renewables. This is just basic circuitry, integrated circuits, and Arduinos, which are more advanced integrated circuits. This is a picture of the game 1830. So those of you who were on the stream before I started, here we go. That's the game 1830, and it's like the granddaddy of the 18XX games. There's the great granddaddy, which is 1829, but nobody plays that. Whereas 1830 is still relatively popular, and if you zoom in on this picture, you can see it's a picture of Scranton, the Electric City. Anyway, I took a photo of that when I was playing 1830 last. Okay, so there's quite a fair bit there of electric vehicles, windmills. Okay, so just whenever I find new stuff on electricity, I post it into that one big mega post. So I created a bit of text on electrical safety just because I didn't think Copeland talked enough about that. And there's motors, generators, difference of AC versus DC. You'll just to make it clear. So this guy here. So this guy here, he says, "Why am I so angry?" And maybe you can't hear that. Let's have a look. Is there going to be an ad? Of course there's an ad. I do like Penn and Teller, but I don't like ads.
To power homes instead of DC. Haven't I showed you that AC is typically more dangerous than DC? Can we run everything on DC? Yes. In fact, pretty much every device at home has to rectify AC into DC first before it can use it. So why? Why am I angry? The reason is elementary. Once there was a fight between a guy named Nikola Tesla being AC and Thomas Edison being DC, and...
Okay, so if I go back to the calcium pictures, hopefully created an album related to that. Oh, I don't have a record album. Oh, there we go. So he said the word rectifiers. So that's why I've got Wreck-It Ralph, because it's about rectifiers. And what rectifiers do is they convert AC into DC. And Tesla, this guy here, he was team AC, and this guy was team DC. So they had what's called the War of the Currents. There's a board game about that. Let me show you. BGG, War of the Currents. And I think they're making a movie about this. So Edison versus Tesla. Let's see how well it's rated. Probably not that highly. Tell you why I'm getting ads on my home computer, because I haven't installed ad blocker on there yet, but yeah, soon. Okay, War of the Currents, rated 7.2. Could be worse. My friends and I, we do say that life is too short to play 7s out of 10, but you'll notice that 1830 was a 7.9. So anyway, so War of the Currents. The Current War. There you go. Maybe it already came out. I don't know if it was any good. Yeah, maybe I'll watch it. I don't know why I saw that being advertised recently. There we go, Cumberbatch. He's okay. Doctor Strange. I enjoyed Doctor Strange. Okay, so that was a fairly big detour while we talked about electricity. So let's go back. Okay, so that's the end of the chapter. And then we have just more drawings, learning about the Australian standards, how to dimension, and materials list. So it's interesting. So dimensioning is in the syllabus, even though you don't get many questions these days. When I was at high school and when I did engineering studies, dimensioning was a huge part of the course. But they didn't have all of the additional stuff that you have to learn, things like aeronautical engineering and all of this electricity stuff. None of that was in the course. And then there's an entire chapter on telecommunications. That wasn't in your course, in my course either. So instead there was a lot more drawing, and the drawing was a lot more difficult. These days drawing is kind of dropping back and back and back. Okay, so doing CAD, I usually do get kids to do CAD in this term, but that could be difficult without access to school computers, so we might have to see what we can do there. Okay, and this is where we'll do the engineering report. You're going to write an engineering report on lawnmowers, but I do have some resources that I can send you guys to hopefully help you out a little bit. Okay, won't be very long. Okay, so now that we've looked at that, and I do want to wrap up because, geez, I have gone on for quite a while now. I'm going to quickly look at the book, and so to do that, that means I have to change. Look, I could try within files. So for Scandium files, I do need to remove some of those pictures. The textbook. So even though I have the textbook open, I don't want to change windows. They call it Scranton. What? The Electric City. So the question is also, how long will this video take to upload? because typically my home upload speeds have been really bad. But I'm getting the NBN today, so who knows? I mean, on one hand, I'm actually optimistic because my neighbor, who actually is a contractor for Telstra, he said that his speeds were really, really good, but a lot of people I've spoken to have been very disappointed with their NBN. So, who knows? So it's a bit of polymers, some more polymers, dun, 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 dun. Communication, with glass there, some communication, and what have we got? Okay, so we're just looking at what we're going to do from here on. Okay, so engineers as problem solvers, I mentioned that in the syllabus, when we're looking at the syllabus. You guys will read that as probably, and let me get you right, a couple of lines summary, some good homework for you there. Historical developments of engineering products, so looking at lawnmowers is the key there. And then, they don't have bikes, it's cars. Okay, but we will still look at bikes anyway. The cars is more interesting. I got confused. We do look at bikes later. Okay, so the effect of these things on people's lives. Yeah, cars is more interesting. I will go through that. I'll talk about that. Okay, we're going to learn about the 4-stroke engine process. So some of you guys who know about cars will already know this. But basically, just there's 4 pitches. Don't be confused by the fact there's 4 pitches and the fact that a lot of cars have 4 cylinders. Even if there was only 2 cylinders, what it's showing is 4 different things in time. This is the first step in time, second step in time, third step in time, that sort of thing. So there's 4 steps: suck, squeeze, bang, blow. Intake, compression, combustion or power or drive or something like that, and then exhaust. So they're the 4 strokes. Now, this is interesting because I used to write this in exams, and my mentor, he's like, yeah, it's not really in the syllabus. And we just looked, it wasn't in the syllabus, unless you're talking about the implication and impact, the historical impact of these things. Now, this is a 4-stroke process. So the typical engine that, if you guys have petrol engines, they're going to be a 4-stroke process. But there's also the diesel process, which is very, very similar. The difference is it doesn't have a spark plug. And then there's also the 2-stroke process. So I will give you some notes on that later. If I looked into, this is probably where I want to go. Is on escape. Go back to calcium, and then go to photos. There should be a photo here on the 4-stroke process. There we go. So, and then I've got a whole bunch of videos on 2 strokes. So this is the video on 4 strokes. This is the video on 2-stroke engines and how they're different. And then this is the video on diesel engines. So that's something we're going to look at. It's not really explicitly in the syllabus, but we'll cover it anyway. Now I'm not looking for the textbook. There we go. Okay, so we talked to the mechanics. We're going to learn about addition of vectors. So this is the addition of vectors. And basically, it's just drawing lines. So if you can add, it's just geometry really, but it's important, and a lot of people do struggle. I won't lie. This is something people do have trouble with. Not lie with. I have some notes that eventually we'll get to. So this is my notes on vectors. Is all on this post. Some of this. So it's a couple of videos of me explaining how to do vectors. And this is the reason why there's so many vectors is because it's vector addition. Oh yeah, right? So that's why that picture is there. So I will start adding that stuff into vectors. Even this picture might get added into that vector picture. This is the video on bikes that I like to talk about. The thing is, I think that video got taken down, but I can find it. It's called Everyday Miracles. We'll watch that later, where we learn about the innovation in bike technology. And let's keep going. Okay, so transmissibility of force and the 3-force method. 3-force method is pretty tough. So I will talk more about the 3-force method later, but the idea is the 3-force method is like an advanced tool, which for some people is useful, right? Okay, if you need to drop out, that's fine. Should put this up as a video. At this point, I'm just going through. I'll only be a minute or 2. Okay, so this is my 3-force method stuff. We're pretty much only a minute or 2 away from being finished. Okay, so 3-force method. Okay, this is we're talking about learning about couples and the application of levers. What order lever is this? Second order lever. There we go. Good answers. Okay, so after we're looking at mechanics, and so I'm skipping through a fair bit. Here's the heat treatment stuff that I talked about. So the heat treatment notes are all here. We've already learned about this stuff about alloys, so that's why that looked familiar when I was talking about it earlier. There's recyclability. Here's the stuff on electricity, right? So these are the symbols, learning about things like voltage, resistance, and whatnot. And AC versus DC current. Now, look, I'll be honest, this stuff on impedance, I just don't do. Lenz's law, I just don't do. I will tell you to read the notes, but I've never seen a HSC question on it. Okay, here's where we learn about motors and back EMF, and then there's a little bit more on drawing and AS 1100 standards. So I skimmed through that end of that chapter a little bit faster, but that's giving you an overview of what we're going to do. For the moment, I'm not sure if I'm going to use a different method. I might use Zoom instead of Discord, but Discord did work relatively well, but I'll see how, maybe if I work with like smaller groups in study sessions, we might use Zoom. I think that's where its strength lies. Okay, so that's it for today. I will send out an email describing some stuff. I'm going to have homework be submitted through Google Classroom, and that is it for today. Have a good one. Bye, guys. Cheers, guys. Have a good one.